In this video, we'll be discussing what is a monostable blocking oscillator with base timing. So, before we go into the classification of this blocking oscillator as a monostable and astable, so we'll slightly know what is this, why does it we call them as a monostable or astable. So if a blocking oscillator needs a single pulse to change its states, then we call them as a monostable blocking oscillator. If the blocking oscillator can change its state automatically, then we call them as a astable blocking oscillator. Okay. So this discussion will be dealing with this monostable blocking oscillator. In particular, we'll be discussing about base timing. Okay, so this is a circuit diagram of an blocking oscillator where we have this base timing. So as you can infer from the system that the pulse transformer that is being connected between a collector and the base of a transistor, as you can see from the figure. So the number of turns in the base circuit is n times as in the collector circuit. A pulse transformer is a transformer one that helps or that accepts the pulse at one winding and produce a similar output on the other winding with 180-degree out of phase. Thus, a transformer is connected in such a way that circuit as shown in the figure. So why do we call them as a base timing? The one thing is that like we can see a resistor R that is being connected in series with the base controls of the pulse during the during the operation. Hence the resistor R that is being connected in series with the base, we call this circuit as a base timing circuit. So if we talk about the operation of this monostable blocking oscillator with base timing. So initially the transistor is an off state. Suppose a positive triggering pulse is applied to the collector to lower its voltage. The device starts drawing current. The current starts flowing in. So the increase in the collector current further lowers the collector voltage, which in turn raises the base voltage of the circuit. Okay, so when the base voltage, whatever that is being gained, when it is higher than the cutoff voltage of a transistor, it starts conducting, which means that so the drawing current from the whatever the supply we give, it starts conducting or it starts taking the input voltage from the supply whatever we give. So in this case, what happens is that so this greatly decreases the collector current. Due to this drop across this transformer winding of the collector also starts increasing. Okay, so this further reduces the collector potential and also increases the base potential. Hence, if we keep allowing more current to pass on, so that results in further drop in the collector potential. Okay, this process can be repeated in loop format, whereas we tends to provide regeneration, and also a transistor is driven into a saturation point. Okay, so in order to obtain a pulse amplitude, what we have to do is that like width and the wave shape of the circuit has to be replaced, which we can do it in our equivalent model circuit. And for an ideal transformer, the sum of the ampere turns is a constant and the induced voltage are greatly proportional to the turns. Okay, so the input voltage whatever we supply, that has a greater influence on the number of coil that is being utilized in the transformer. Okay. And if we talk on the wave outputs or the uh, waveforms of the monostable blocking oscillator, you can see with respect to the pulse input whatever we have, we were able to get a required output voltage. And the great disadvantage of this waveform or the monostable blocking oscillator is that the output pulse with whatever we get, so it cannot be maintained stable. So there will be a change in the width of the output whatever we get. So this is the one disadvantage of this particular circuit with base timing. So thank you.